Okay, question number 47. For a greater than b greater than c greater than 0, the distance between 1 comma 1 and the point of intersection of the lines ax plus by plus c equals 0 and bx plus ay plus c equals 0 is less than 2 root 2. Then which of the following conditions is satisfied? This is the question. I repeat, a, b, c, the relation is given. A is greater than b is greater than c is greater than 0. The distance between 1, 1 and the point of intersection of two mentioned lines. So first I have to find the point of intersection of the two lines fast. Ax plus by plus c equals 0, bx plus ay plus c equals 0. I multiply first equation by a and second equation by b. What will happen on subtracting b's? Y is cancelled out. We get direct solving ax plus by plus c equals 0 and bx plus ay plus c equals 0, we get x equals minus c upon a plus b. Correct? Because y is cancelled out, we are getting a square minus b square into x plus ca minus cb equals 0. So we get x equals minus c upon a plus b. Then we can put back the value of x to get y, or if I direct subtract the two equations, I will get x equals y. Means the point of intersection of these two lines is lying on the line x equals y, means y is also coming out as minus c upon a plus b in order to save my time. So x and y are obtained as this one. Now the question says square root of 1 plus c upon a plus b whole square plus 1 plus c upon a plus b whole square is less than 2 root 2. Correct? This is same. So we can write simply root 2 times the entire thing. Root 2 is cancelled out. Modulus, no need of it because a, b, c all are positive. We are getting a plus b plus c upon a plus b is less than 2. Correct? So cross multiply and simplify. Why we can cross multiply? Because a and b both are positive, so it will not change the inequality. We get a plus b plus c is less than 2a plus 2b, or a plus b minus c is greater than 0 as the solution of it. A plus b minus c is greater than 0 means the correct answer for this question is, we can see from the options, option A. Correct? So answer is A. Let's move to the next question, that is question number 48. Let's talk about the question number 48. Let complex numbers alpha and 1 upon alpha bar lie on circles x minus x naught whole square plus y minus y naught whole square equals r square, and x minus x naught whole square plus y minus y naught whole square equals 4r square respectively. If z naught, that is x naught plus iota y naught, satisfy the equation 2 mod z naught square is equal to r square plus 2, then mod alpha equals, we have to find the value of it. 4 options are given. So the complex numbers alpha and 1 upon alpha bar are satisfying these two circles respectively. Correct? So alpha is lying on the first circle. What is the first circle? First circle can be read as z minus z naught ka modulus is equal to r, that is mod alpha minus z naught is equal to r, because alpha is satisfying first equation. Second, 1 upon alpha bar is satisfying second equation, means 1 upon alpha bar minus z naught is equal to 2r. Correct? From the first equation we can say that alpha minus z naught multiplied with alpha bar minus z naught bar is equal to r square. Simplifying, we get mod alpha square minus alpha z naught bar minus z naught alpha bar plus mod z naught square is equal to r square. Similarly, from the second equation, we can read it as 1 minus z naught alpha bar into 1 minus z naught bar alpha is equal to 4 r square mod alpha square. Simplifying this equation, we get 1 minus z naught alpha bar minus z naught bar alpha plus mod z naught square mod alpha square is equal to 4r square mod alpha square. Right, now we have two equations. So let's say this is 1, this is 2. When I subtract these two equations, I will see that alpha z naught bar and alpha bar z naught, this is cancelled out on subtracting the two. Mod alpha square minus 1, so let's writing it mod alpha square minus 1, other two terms are cancelled, correct. Next, this is mod z naught square, here mod z naught square alpha mod square, so subtraction here again, so plus mod z naught square times 1 minus mod alpha square is equal to, on the right hand side we have r square minus 4r square mod alpha square, that is r square into 1 minus 4 mod alpha square, correct. So what we are getting on the left hand side, we can write it as mod alpha square minus 1 multiplied with, when we have taken this term common, we get 1 minus mod z square, 1 minus mod z naught square is equal to r square into 1 minus 4 mod alpha square. Now my objective is to get the value of mod alpha, correct. One more condition is left which I have not used yet. It is 2 mod z naught square is equal to r square plus 2, correct. I can read this equation from here, r square, correct, it is required here, I can put it in this equation, fine, r square, or what I can say is this given equation can be rewritten as, since twice mod z naught square is equal to r square plus 2, that is, if I take this 2 on the left hand side, I have 2 into mod z naught square minus 1 is equal to r square, that is the value of r square is 2 times mod z naught square minus 1, or correct. Let's put this value here in this equation. In this equation, when I put the value of r square upon mod z naught square minus 1, it is eliminated. I get mod alpha square minus 1 is equal to, this is r square upon 1 minus mod z naught square minus 2 into 1 minus 4 times mod alpha square. Just the simplification part is left, that is minus 2 plus 8 mod alpha square, this is mod alpha square minus 1, or giving me mod alpha is equal to, this is 7 mod alpha square is equal to 1, so mod alpha is 1 by root 7. So in this manner we obtain the value of mod alpha as 1 by root 7, which is option number C. So correct answer for this question is C, again uncoded. Fine, let's go to the next question, that is 49. Okay, let's talk about question number 49. The number of points in minus infinity to infinity for which x square minus x sin x minus cos x is 0 is. So I have to find the number of points for which this equation is satisfied. If I differentiate by considering it as fx, I get 2x minus sin x minus x cos x plus sin x. If I say this is equal to 0, what I am obtaining, this sin x is cancelled out, correct? Basically f dash x is coming out as 2x minus x cos x. So it is x into 2 minus cos x. When I equate to 0, I get the root as x equals 0 only. I can clearly see that the function fx is increasing if x is greater than 0 and fx is decreasing if f is less than 0. The shape of the curve will come out as function is increasing means upside, decreasing means downwards, correct? Now when I substitute x equals 0 in this function, what I obtain, x equals 0 means 0 minus 1. So the value of the function at x equals 0 is minus 1, and 0 is the important point which is deciding the change in nature of the function, means function will move in this manner somehow. Clearly it is intersecting x-axis at two distinct points. So the number of roots of the equation, it is simply 2. So the answer is C. So it's decoded in this manner, we get the answer as C. Next, question number 50. The area enclosed by the curves y equals sin x plus cos x and y equals modulus of cos x minus sin x over the interval 0 to pi by 2. So the important part for this question is the tracing. Y equals sin x plus cos x, multiply by root 2 and divide by root 2 to get root 2 into sin x plus pi by 4. We can draw this curve as shown, correct, over the interval 0 to pi by 2. Fine, this is the curve y equals sin x plus cos x. Now modulus of cos x minus sin x, if I talk about the curve simply cos x minus sin x in the interval 0 to pi by 2, I can observe again multiply divide by root 2, it will change to sin x minus pi by 4 type, it will go in this manner. Correct? The required area is area enclosed by this first curve minus area enclosed by the second curve. I can see, say A1, the first part by the upper curve. A1 is 0 to pi by 2 sin x plus cos x. Either you can write it direct or you can put it like root 2 times sin x plus pi by 4 into dx. Root 2 sin x plus pi by 4 dx. That will give you simply minus root 2 cos x plus pi by 4 0 to pi by 2. Correct? When you put pi by 2, it becomes simply cos 3 pi by 4, that is minus 1 by root 2. When you put 0, it is 1 by root 2. So it simply becomes minus root 2 multiplied with minus 2 by root 2 or 2. Let's talk about A2. A2 is integral 0 to pi by 2 modulus of cos x minus sin x, or root 2 times mod of sin x minus pi by 4. You can clearly see when you replace x by pi by 2 minus x, it is unchanged. It is unchanged, so you can write it as twice of simply 0 to pi by 4, correct? 0 to pi by 4 cos x minus sin x here. Integrate it, simplify to get the result as 2 times root 2 minus 1 or 2 root 2 minus 2. Fine. Now the required area A1 minus A2. Area required is A1 minus A2. So it becomes simply 2 minus 2 root 2 minus 2, that is 4 minus 2 root 2 square units. 4 minus 2 root 2 square units. Now look at the given options. We can take clearly 2 root 2 common, On taking 2 root 2 common, it gives me root 2 minus 1 inside the bracket. So we get the correct answer as B. So the correct answer for the question is B. So in this manner, this is the question number 50. Let's go for the next question, that is question number 51.